Yeah, so the the slide deck I'm using here is tailor-made for the 30-minute speaking time and 15 minutes question. So I have simply to speak a little faster, right? No, I'm flying over the first part of the presentation really quick so that I can spend a reasonable time when we look at LINSTOR. So usually I would explain what Linux has in it and which components we can use to build our storage system out of. So you know there's a LVM in Linux and it has some features and it supports thin provisioned volumes. And the only thing you should capture from this slide is that the thin pool is just a regular logic volume from the older part, and then you get out of that, you get thinly allocated LVs and snapshots of those. There is RAID in Linux, you know that. There is functionality in Linux to use SSDs as caching devices for rotating media, or maybe PMEM for SSDs. There's deduplication in Linux. That's available since RHEL 7.5 or CentOS 7.5. It's not yet available in the upstream Linux kernel, but there are some engineers on the Red Hat payroll to bring it upstream. But as we know, this might take 12 or 24 months, depending on all the maintainers. There is targets and initiators, and there is, in case you happen to use Ubuntu as your base distribution, you have CFS or ZFS readily available as one of the tools in your storage toolkit. Now then, there is DRBD. So for those of you who are not familiar with it, just try to understand this slide for a second. So it is like a RAID 1 sitting on top of a local storage device and an initiator. And on another node where you have the target, there is another copy of your data. And the right-hand side of the slide, no, from your side, the left-hand slide. This is where your application sits on top of the RAID 1, right? Your VM in case of OpenNebula. So we call that the primary in DRBD speak. And the replica, yeah, that's the secondary. So it got a number of bells and whistles over the year, like consistency groups, like it's not a 2-node thing, it's a 32-node thing if necessary. But not all the nodes need to have a local replica. So this is something that comes in very handy for your OpenNebula cluster. And there are many, many features, and I could spend a whole hour speaking about each of the features. Yeah, and development didn't stop. We have many things we want to do. Maybe the only to mention is that we are optimizing it more for PMEM and NVDIMMs, as finally the major hardware vendors have that readily available. So we will optimize our metadata to take advantage of when you have a block storage on PMEM, that you can actually access the data on a cache line granularity. So not enough that PMEM is a lot faster than an SSD. You're even faster if you just update 16 bytes instead of 512 bytes or 4K. And there's a lot of more work on the RDMA side of things. And with a little EU money, we will also bring erasure coding to DRBD that is supposed to land in 2019. Now let's talk about LINSTOR. So the idea of LINSTOR is that we take all these parts we have in the open source world, you know, LVM, CFS, DRBD, because you can combine all these parts on the data plane. You know, it's like plumbing. You can stick these things together, right? You can use your RAID 1 and then put your LVM on top and so on. But for each of these things, you have your own tools, you know, and they are incompatible. You need to learn a new tool for all these things. So they're not compatible on the, let's call it control plane. And this is where LINSTOR comes in. The idea is, it is a distributed system sitting on all your nodes, and it configures all these details for you. And you get an API and a CLI on top of it, where simply can create replicated volumes, and it will use the LVM or CFS to carve out these volumes out of your storage devices and make that accessible to your KVM instance running a VM. So yeah, we not only support OpenNebula, there are also connectors to Kubernetes, OpenStack, and it's all open source. So to make your picture in mind a little more clear, in case you have distinct hypervisor and storage nodes, it could look like that. And obviously, we can lose a hypervisor node, no problem. We simply access the same storage. If we lose a storage node, well, still the VM continue to run. Now it's only one replica. Now, how does the system react in case we lose a storage node? It does nothing. Why is that a good idea? Because if you immediately start to do crazy rebalancing of the data, and then after 2 minutes, the node comes back because it was just rebooted, you ended up, it was not a good idea, right? So our philosophy here is it's up to the admin, up to you, up to your monitoring to figure out what is the situation, tell LINSTOR, okay, this storage node was lost. So LINSTOR node, blah, blah, lost. And then it will rebalance for you, right? Not automatically. Now, when we look at hyperconverged, I need to add that that the system is very well suited for hyperconverged. Why that? Because it uses very little CPU and it uses very little memory. So when you compare it to Ceph, we use about 5% of the CPU Ceph would use. And also memory consumption is nothing compared to Ceph. So it's very well suited for that. And ideally, you would place it like that, right? Having a local replica beneath your VMs, because all your read accesses are local accesses. Only writes touch the network. And it will always be the network will be a crucial part of your SDS system. Now, what happens, you know, we have too much load there, we need to migrate the VM. Now, it's not that nicely optimized, right? We need to access, or we need to touch the network even for reads now. Okay, again, so it would be a simple command on the LINSTOR command line interface. You tell it, okay, allocate a local replica as well. Then DRBD will do its resync, bring the volume up to the same data. And after the resync is done, you would remove the third copy because in this case you only want to have 2. And it's optimized again. Okay, then quickly about the architecture. So LINSTOR has a controller part. This is the part that, you know, does all the decisions. We call it LINSTOR satellite. That's the node agent. Satellite is completely stateless. Yum install, you're done. The controller has an embedded SQL database. The controller isn't involved in I/O at all. So as soon as the volume is set up, you can stop the controller, you can restart it. But you want to have it HA in some way, right? And the preferred way of running the controller is to run the controller in a VM and let that be kept highly available by OpenNebula itself. Because then you don't need to learn another tool to have the controller HA, just rely on OpenNebula, you run it anyways, right? So you will find the details how to bootstrap that in our documentation. It's a little bit tricky, right? Setting up DRBD first, then move the controller into the VM, but it's doable. So there are a few interesting things on the roadmap, and there is a big name customer that gave us this statement. We might mention him. And since this is a lightning talk, this is it. And now I'm looking forward for a few questions.